Assalamu alaikum students. Our today's topic is covalent bond. Let's see first of all definition of covalent bond. Covalent bond is formed by a mutual sharing of electron pairs provided by the bonded atom. So in this case electron is shared and electron is not transferred. It is not lost or gained, but it is shared between the two bonded atoms, and each atom will provide one electron in case of single covalent bond. And there are three types of the covalent bonds. Single covalent bond, in which a single electron pair is shared between the bonded atom. Another type is the double covalent bond, in which each atom shares two electrons. And third type is the triple covalent bond, in which each bonded atom share three electrons. And these bonds are represented by single line if covalent bond is single, and it is represented by a double line, two lines if it is double covalent bond, and if there is triple covalent bond, then it is represented by three lines. So the mutually shared electron pairs are shown by dot or a cross. One of the electron from one of the element is shown by dot, and the other element is shown by a cross. Now we will see different examples of atoms in which covalent bond is formed. First example is the hydrogen molecule. Formation of hydrogen molecule. Hydrogen is the most simplest and smallest atom, in which each atom has one electron in its valence shell, which is represented here in the form of cross. In another hydrogen atom is represented by this black circle. So each hydrogen atom has one electron. When these two hydrogen atoms will approach each other, then there will be two type of forces. One is attractive and other is repulsive. At a certain distance, attractive forces will dominate, and these two hydrogen atoms will share their electron in such a way that this electron pair lies in the center of the line that is joining the two nuclei. So here is the nucleus of one hydrogen atom, and on the right side is the nucleus of other hydrogen atom, and on this axis these two electrons will lie in between the two hydrogen atom, and this electron pair will be shared equally by the two hydrogen atoms, and it can be shown by dot and cross formula, and this single line representing single covalent bond because only one electron is shared by each bonded atom. Another example here is the chlorine molecule formation. In chlorine, valence shell has 7 electrons, so only valence shell is shown here, not the other electron configuration. So in valence shell, 7 electrons in one chlorine atom and 7 electrons in the other chlorine atom. Each chlorine atom requires one electron, and they will share their electron to complete their octet. So chlorine atom will combine with another chlorine atom, and this electron pair will be shared by the both chlorine atom, and it will be present in the line which is joining the two nuclei. So it will be in the center of the two atoms. This bonding can be shown by electron dot and cross formula, and on the right side the single line is representing that single bond is present, and these electrons which are represented on the opposite sides, these electrons are the lone pairs. These are not participating in the bond formation. Another example is of oxygen. Oxygen can form double covalent bond because each oxygen atom will share its two electrons. Again, valence shell of oxygen is shown, in which it has 6 electrons. So it has to share two electrons to complete its octet with the other oxygen atom. So in this case, two electrons will be shared by one oxygen atom and other two electrons will be shared by the other oxygen atom, and in total there will be four electrons that are present in the center of these two nuclei, and these will be mutually shared. An electron and dot and cross formula is also given. In this case, these four electrons are the shared electrons, and these four electrons or two lone pairs are present on each oxygen atom. This double line is representing the double covalent bond. Each line represents an electron pair. Another example is nitrogen. Nitrogen molecule is formed by mutual sharing of three electron pair from each nitrogen atom, and this type of covalent bond is triple covalent bond. So valence shell of nitrogen contain 5 electrons. Each nitrogen atom will share its 3 electrons, and in total 6 electrons will be present in the center of the nuclei of the two nitrogen atoms. An electron and dot and cross formula of the nitrogen is given here. These are the shared electron pairs, and each nitrogen atom has one lone pair which is not bonded, and triple bond can be represented by three lines which are present in the center of the two nitrogen atoms. Now there are some examples. Formation of covalent bond in water. So water is a covalent compound. Water molecule is formed when two hydrogen atoms share their electron separately with the electron of one oxygen atom. So oxygen needs two electrons to complete its octet, and it will share electrons with two hydrogen atoms to form the water molecules, and octet of the three atoms will be completed. So in this case, this electron pair is shared between this oxygen and hydrogen, and this electron pair is shared between this oxygen and hydrogen, and water molecule is formed in which oxygen has made two covalent bond, one with this hydrogen atom and other with other hydrogen atom. This molecule formation can be shown by dot and cross formula, in which oxygen is forming single covalent bond with the hydrogen atom and another single bond with the other hydrogen atom, and it has two lone pairs, and overall it has 8 electrons in the valence shell, and it can be shown by this representing this single line which is representing single covalent bond. Another example is carbon dioxide. Carbon dioxide in molecule is formed when an atom of carbon shares its 4 electrons with two oxygen atoms. Each oxygen atom shares 2 electrons. So this example represents double covalent bond, in which carbon form double covalent bond with each oxygen atom that is present on the right and left side. So oxygen has 6 electrons in the valence shell, carbon has 4 electrons in the valence shell. So this carbon will combine with oxygen atom and shares its 2 electrons with the oxygen. In total 4 electrons are present in the center of this carbon and oxygen. In the same way, this carbon will form bond with other oxygen atom. These double bond will represent 4 electrons that are present between carbon and oxygen. So electron dot and cross formula is given here for both double covalent bond here, and these 4 electrons also representing double covalent bond, which can be shown by these double lines. Another example is of ammonia. In case of ammonia, nitrogen has formed 3 single covalent bond with 3 hydrogen atom, in which one electron pair is present between each hydrogen and nitrogen atom, and nitrogen has one lone pair which is shown on the top of the nitrogen molecule. So this bond has been shown by a single line On the right side, there are three single covalent bonds and one lone pair in ammonia. Another example is hydrogen cyanide, which is represented by HCN. In this case, carbon has formed three triple covalent bonds with the nitrogen and single covalent bond with the hydrogen, that is on the left side. It has one electron pair in the center of the carbon and hydrogen, and it has three electron pairs in the center of carbon and nitrogen and one lone pair on the nitrogen. It has also been represented by showing single line for covalent bond and triple line for the triple covalent bond that is present between carbon and nitrogen in HCN, which is hydrogen cyanide. Another example here is methane. In methane, carbon has formed bond with four hydrogen atoms. Carbon has four electrons in the valence shell. It requires four electrons to complete the octet. So it will combine with four hydrogen atoms. Each hydrogen atom has one electron in the valence shell. So it will form four single covalent bonds with four hydrogen atoms, and octet of the both carbon and hydrogen will be completed. Here electron dot and cross formula is shown, and bonds that are present between the carbon and hydrogen are also shown here. Another example is ethene. In ethene, C2H4 is the molecular formula. In this case, one double bond is present between carbon and carbon, and other bonds are single covalent bond which are present between carbon and hydrogen. Each carbon is forming two single covalent bonds with two hydrogen atoms on each side and one double bond. These bonds can be shown by dot and cross formula. These double bonds are shown by two electron pairs between carbon atom, and this single bond is representing one electron pair that is present between carbon and hydrogen, and similarly these bonds are present in other hydrogen and carbon bonds. Another example is methanol, which is also called methyl alcohol. Its molecular formula is CH3OH, in which carbon is forming three single covalent bond with three hydrogen atoms, one single bond with carbon and oxygen, one single bond between hydrogen and oxygen. Oxygen also has two lone pairs which are not participating in the bond formation, and these are represented above and below the oxygen atom. Electron dot formula, dot and cross formula is also shown on the right side, which is showing the single covalent bonds that are present in methyl alcohol. Now we will solve the exercise question about this topic. Draw electron and dot and cross structures of following compounds, which are SiH4, PCl3, SO2 and SO3. Dot and cross formula of the silicon tetrahydride is given here, in which each silicon atom form four single covalent bond with four hydrogen atom. So this electron pair is showing single covalent bond that is present between silicon and hydrogen, and there are four single bonds 1, 2, 3 and 4 between silicon and hydrogen atom. So electron from the silicon is shown by this dot, and electron from hydrogen are shown by cross. Other example is PCl3. In case of PCl3, phosphorus is forming single covalent bond with three chlorine atom, and each sharing one electron to form single covalent bond. In this case, single covalent bond is present between this phosphorus and chlorine. Another single bond is present between others chlorine and phosphorus, and third covalent bond is present with the third chlorine and phosphorus. And phosphorus also has one lone pair which is present at the top of this molecule. Third example is SO2 sulfur dioxide, in which sulfur is forming double covalent bond with the oxygen atom. On the left side, sulfur is forming double covalent bond with the oxygen atom, and it has been shown by 4 electrons which are present between sulfur and oxygen atom, and each oxygen atom has two lone pair, 1 and 2 lone pair is present on each oxygen atom. On the same way, on the right side, sulfur is forming double covalent bond with other oxygen atom, and it also has two lone pairs on oxygen atom. Sulfur trioxide. Sulfur trioxide is forming double covalent bond with three oxygen atom. On the left side, these 4 electrons are present between sulfur and oxygen, and each oxygen atom again has two lone pairs. On the right side, sulfur has double covalent bond with the oxygen atom, and it has two lone pairs. It also has double covalent bond with the other third oxygen atom, and two lone pairs on the oxygen atom. So sulfur is forming double covalent bond with three oxygen atoms.